Welcome back to part 2 of our video for reviewing factoring polynomials. So I wanted you to come into this class with good skills on factoring polynomials because you have to use it frequently in a pre-calculus class and in a calculus class. In the first video we talked about strategies, which I have teeny tiny here over to the right. Let me make that bigger for you. Let's take a look. So a strategy for factoring a polynomial: is there a greatest common factor? That's step one. Always look for that. I tend to forget sometimes. And you can still factor your problem without pulling out a greatest common factor sometimes, and then you could do it later, but it's really smarter to do it at the beginning. So step 2 is looking at various options. So if you have two terms, then you could either have a difference of squares, a sum of cubes, or a difference of cubes. Notice a sum of squares is not on this list because that's not factorable. B, if there are three terms, you need to be able to factor the trinomial. And in this video, I really want to focus on some techniques for factoring a polynomial with three terms. In other words, a trinomial. We talked about if four terms, you would have a factor by grouping, and we may run into that in this video as well. And then finally, step 3 is look at your factors and see if you can't factor again. So if we go back to our particular problem, here we are with our strategies teeny tiny over here on the right. Notice this is strategy 2b. We have three terms, and this is called a trinomial. When you have a trinomial, here's what needs to happen. It needs to be in descending order, which means the square term is first, the x term is second, and the constant term is last. If you have a leading coefficient of 1, then you handle it one way. If you have a leading coefficient of not 1, then you handle this a different way. Okay? So here's what I'm going to do. If there's a leading coefficient of 1, what I want to do is find numbers that multiply to be the constant. In our case, the constant is 15. So multiply to be constant, and at the same time, these same two numbers add to me the x coefficient. Now, your variable in your problem might not be x. It might be something else. But that's what we need to do. We need to find two numbers that multiply to be the constant and add to be the x coefficient. So in our particular problem, we're going to find numbers that multiply. I'll put MLT for multiply to be 15. And at the same time, those two numbers add to be 8. Now here's the deal. If your polynomial factors, then you will only find one set of numbers that works. Okay, so we think about the numbers that multiply to be 15. You're talking about 1 times 15. That adds to be 16. It doesn't add to be 8, so that's out. Or 3 times 5. That multiplies to be 15, right? And it adds to be 8, so that's our winner. 3 and 5. There's no other set of numbers that's going to work. So you're not going to be worried about finding multiple ways this can be done. There's only going to be one way or no way this can be done. Now the next step is, what do you do with those two numbers? Okay, well, write you a set of parentheses. These are both plus, so I put plus 3 and plus 5. And then the square root of that goes in the first box. So the square root of x squared is x and x. And this is your problem factored. Now you know, just like all the other factoring problems, you can check this. I could say x times x is x squared, x times 5 is 5x, 3 times x is 3x, and 3 times 5 is 15. Notice we're not finished with our check. You can add like terms there in the middle. And notice I got my original problem back. So this factoring is correct. Okay, so again, if you have a leading coefficient of 1, then you multiply to be the constant term and you add to be the middle term. Let's try another one. Okay, so this time notice we have a leading coefficient of 1. It is in descending order, as it should be. So we're trying to find numbers that multiply to be -5 and add to be the middle coefficient, -4. You see that? So multiply to be the constant and add to be the middle number, -4. Now you have to start thinking of numbers that multiply to be -5. Now let's wait a minute. To multiply to be a negative number, you need one positive and one negative. Now, this problem's not too bad because 5 only has two factors. It's 1 and 5. But again, for it to be negative, it's either -1 and +5 or +1 and -5. Now, which one of those adds to be -4? Well, it's not this one because that adds to be +4. This is our pair of numbers, okay? So then again, remember you write two sets of parentheses. You put those numbers in there. That's a +1, so I put +1, and -5, so I put -5. And I take the square root of my square, okay, or first term, and that goes in the first position on each of our factors. Now notice it wouldn't matter if you put x minus 5 first and x plus 1 second. That's the commutative property of multiplication. The order you multiply in does not matter. What matters is that the negative is with the 5 and the positive is with the 1. And of course you could check this just like we checked the last one if you wanted to. Alright, so problem 12. Let's look to see if there's a greatest common factor. So I see a 14, a 45, and a 1. So no, numerically there's no greatest common factor. And I see an x, no variable at all, and an x squared. So there's nothing common to all three of these terms. What I'm noticing next is it's got three terms. So that's what we call a trinomial. And in trinomials, it's always easier to look at them when they're in descending order. So I'm going to write the x squared first, the -14x second, and the +45 last. Now that's the commutative property of addition. It is okay to rearrange your terms as long as you take the sign. So that was a -14x. It stayed a -14x. That's a +45. It stayed a +45. That's a positive x squared, so I put x squared. I didn't have to put the plus in front because it's implied positive. Now I know it's a trinomial, so I'm trying to find numbers that multiply to be 45 and add to be -14. Now notice when I start making my list, I'm only worried about multiples. I'm not guessing things that add to be -14. We could do that all day long. I am making a list of things that multiply to be 45. Now here's another trick. Multiplies to be 45, you could do, say for example, 9 times 5, right? But there's no way that's going to add to be a -14. It turns out to when you multiply to be a positive and add to be a negative, they both have to be negative. Both of our numbers are going to be negative. Now, again, 45, there's lots of factors that give me 45. Like, I'm going to go over here to the left. 3 times 15 gives me 45, right? 9 times 5 gives me 45. 1 times 45 gives me 45. And there's probably more. Let's see. Or maybe not. But if they're both negative and they add to be -14, then this is the winner, right? This adds to be 18, and if they were both negative, it'd be -18. This would add to be a -46, so a -9 and a -5. And remember, there's only one way you can do it, or no ways. So that means this factors immediately into x minus 9 times x minus 5. And you could certainly check it by foiling this out using the distributive property and making sure you get your original expression back. Now this problem is different, okay? So first let's follow the rules. Is there a greatest common factor? Is there a factor that divides into each of these? And there's not. 2, 5, and 3 don't have anything in common. There's not an x in common to all three of these terms. So that's out. So I move on to strategy number 2, which is really asking yourself how many terms does it have. If it has 2 terms, it might be a difference of squares or a sum and difference of cubes. If it has 3 terms, then we can do these techniques for a trinomial. Alright, now, the last 3 problems that we just did had a leading coefficient of 1. This is new, and I have a strategy for you. A lot of people do this by trial and error. I am not opposed to that, but it is a technique that you definitely need to practice, and you need to check to see if you did it correctly. I don't like teaching trial and error because it's not really teachable. It's just something you practice. But on the other hand, 2x squared plus 5x minus 3 can also be done in like a factor by grouping technique. There's a few steps to getting it done, but it's possible and a lot of people like it. So here's what you do. You multiply. I'm going to erase this circle right here. Okay, you multiply the leading coefficient times the constant, and that gives me -6. So I'm trying to find numbers that multiply to equal -6. So you see what I did there? I did 2 times -3. Instead of just grabbing the -3, when there's a leading coefficient here, I need to multiply those together. So multiplies to be -6 and adds to be +5. So just like in the last problem, except we have this extra number we multiply in the back for a multiply number. Now let's think about all the things that multiply to be -6, like a 6 and a 1, but to be negative, one's positive and one's negative. So if I did a -6 and a +1, that's not going to work, right? Because that adds to be -5. So that's out. What if I did a +6 and a -1? Hey, that does add to be +5. So those are our two numbers. Now, here's the extra steps here. Because of this extra 2 up front, I can't just write x plus 6 times x minus 1. That's not going to work. That's the trial and error method. We're not doing that. Okay? What I do is I rewrite the middle term 5x. So 2x squared stays the same. I replace 5x with plus 6x minus 1x minus 3. Notice that right there is our two numbers. But I put whatever variable is in our problem with it. If I combine these back together, I will get my original problem, right? So all you're doing is rewriting this middle term. Now I do what's called factor by grouping. Now we did one problem in the last video where we did factor by grouping. We're going to do another one now. Factor by grouping means you group the first two terms together and the last two terms together and factor out greatest common factors. So the first two terms, notice there's a 2 in common and an x in common. So I'm going to pull 2x. Now if I divide this by 2x, notice the 2's cancel. X squared over x is just x. And then this divided by 2x, the x's cancel. 2 goes into 6 3 times. If you distribute that back in, you would get 2x squared plus 6x, just like we expected. Now to do factor by grouping, whatever you pull out of the second one that's common, you might look at that and go, they don't have anything in common. But that's okay. You could pull out a positive one or a negative one. In this case, we need to pull out a negative one. Reason being, we still have to be left with x plus 3. And when you pull out a negative, it changes both of those signs. Now remember, you're not done here either. You have x plus 3 times what's out front, 2x minus 1. Okay, so x plus 3 times 2x minus 1. Is that completely factored? How do you check it? Multiply it back out. What was new about this problem? We had to multiply the 2 times the 3. So whenever you have a leading coefficient that's not 1, you have some extra steps to do. And factor by grouping, to me, is the easiest way to do those extra steps to get this problem handled. Yeah, I thought you might benefit from seeing that again. So again, this is a trinomial. Notice it is in descending order. There is no greatest common factor. There's not anything that divides into both 3, 2, 5, and x squared, x, and no x at all. So what I'm going to do is multiply the first times the last together. So I'm going to find numbers that multiply to be -15. Again, 3 times -5 is -15. And add to be -2. Okay? So what you got to do is start thinking about all the things that multiply to be -15. Like a 1 and a 15. Or the -1 and a positive 15, but that doesn't add to be -2. You could also do a positive 15 and -1. That still doesn't add to be -2. What if we did 5 and 3? But one's got to be negative because that's the only way you multiply to be a -15. If we do a -5 and a positive 3, that does add to be -2. That's our winner. So now you don't write your answer as x minus 5, x plus 3 because of this extra 3 here. What you have to do is rewrite your middle term. So 3x squared stays the same. And I'm going to replace -2x with -5x plus 3x minus 5. Okay? And now I'm doing factor by grouping. So I look at my first set and I say, what can I factor out? So if I pull out an x, because that's the only thing that's common, it's going to leave me with 3x minus 5. Here, they don't have a thing in common, do they? But look, it's already 3x minus 5, so you're really factoring out a 1, which does not change at all, but it helps you with the last step. Remember, you write the factor that matches times what's remaining out front, x plus 1, and that is completely factored. I think after you practice that a few times, you'll feel much better about it. Okay, folks, here's another one. Is there a greatest common factor? 6, 15, 19. Is there anything in common to all three of those? Nope. They also don't have a variable in common, so strategy 1 is their greatest common factor, done. Strategy 2, we jump straight to B because there's 3 terms. Now, if we have 3 terms, we really need those written in order. So this is what we have, okay? And I'm going to do that step where I multiply 15 times 6. Now, everybody doesn't know right off the bat what 15 times 6 is. You type it in your calculator and you get 90. So I need numbers that multiply to give me positive 90, and at the same time they add to give me negative 19. Now, folks, you know this. The only way you can multiply to get a positive number, but add to get a negative number, is if they're both negative. So the numbers we're working with have to both be negative, okay? All right, so again, multiplies to be 90. What kind of things multiply to be 90? I know 90 and 1 certainly aren't going to add to 19, or 45 and 2 are not going to add to 19. So you might be thinking the more obvious, some of you jumped here immediately. How about 9 and 10? And both negative. Let's check it. Negative 9 times negative 10 is positive 90. And negative 9 plus negative 10 is negative 19. Yeah, we're good. Now remember, the next step is don't write x minus 9, x minus 10. That only works when you have a leading coefficient of 1, which we do not have. We're going to rewrite this middle term. So the 15x squared stays 15x squared. I could put minus 9x minus 10x plus 6. I factor out a greatest common factor out of the first 2 terms and one out of the second 2 terms. So when I look at the first 2, I see that 15 and 9 are divisible by 3, and they both have an x, and an x to the first is the biggest I can pull out. So if I divide 15 by 3, I get 5, and this x and one of these x's canceled, it gives me x. Okay, 3 goes into 9. By the way, the minus comes down. 3 divides into 9 3 times, and x cancel, okay, when you divide. All right, now here I'm looking for what's common. I got a negative 10x and a plus 6. Okay, now I know they have a 2 in common, no x but just a 2. If I pull out a plus 2, watch this, I'm going to erase, but I'm going to pull out a plus 2. That's going to leave me with negative 5x plus 3. You see that didn't work? Because these have to match. So instead, I'm going to erase this entirely, because we didn't do it right. Instead, I'm going to pull out, or factor out, a negative 2. Now, if I factor out a negative 2, negative 10 divided by negative 2 is positive 5. The x is still there. Positive 6 divided by negative 2 is a minus 3. Now they match, and when they match, you write down the factor that matches only once times what's out front, 3x minus 2. And that is completely factored. All right, so now we've moved on to problems that just say factor completely. They're not a group, they're not all trinomials, they're not all factored by grouping, they're just various problems, and that's of course what you're going to be presented with when you are working with your pre-calculus and calculus problems in the future. So the very first step, is there a greatest common factor? If there is, let's pull it out. So they both have a 5x in common. Let's pull that out. So if I pull out a 5x here, notice I'm left with x squared. And if I pull out a 5x here, remember I'm dividing, I'm left with minus 9. Okay? But I'm not finished, because this, if I start moving down my strategies here, right here, that's a difference of squares. So the 5x is still part of my answer. And when you have a difference of squares, now how do you know that? First of all, difference means subtraction. X squared is a perfect square, so I take the square root of x squared, that goes in the first position. And then 9 is a perfect square, so the square root of 9 is 3, that goes in the second position, and you have to have it memorized that one's plus and one's minus. And this is what we call completely factored, because none of these factors will factor further. All right, let's try the strategy again. Factor completely. So always look for a greatest common factor first. Notice both of these have a y, so I'm going to factor out the common y. It's going to leave me with y to the 4th power minus 16. And then what you do is you look at what's remaining, okay? So the y will not factor further, but y to the 4th minus 16 is a difference of squares. So a difference of squares, remember you write 2 sets of parentheses with 1 plus and 1 minus. Then you take the square root of the first term, y to the 4th, square root of that is y squared. The The square root of 16 is 4. That goes in the second position. But we're still not factored completely. Now y is done. Y squared plus 4 is also finished because that's the sum of squares and it doesn't factor further. Y squared minus 4 will factor more. So I have y squared plus 4, which is finished. And then I have two sets of parentheses where I take the square root of the first term, which is y in the first spot. The square root of 4 goes in the second spot, again with 1 plus and 1 minus. So there's a lot going on there. Greatest common factor, a difference of squares, and then we had another difference of squares to get the y plus 2 times y minus 2. I promise you, if you took the time to multiply all this back out, which would take longer than the factoring we just did, you would get y to the 5th minus 16y as your result. Okay, let's go down the steps. Is there a greatest common factor? So I see a 2, and 112, and what I know about that is 2 divides into all of those. So 2 divides into 2 one time. So the x squared just comes down. It's like a 1x squared. 2 goes into this 2 one time. So it's like I'm pulling down a minus 1x. And 2 divides into 112. How many times is that? So was that what? 56? Okay. So minus 56. But now this can be factored again. And if you'd rather look at it as x squared minus x minus 56, that's certainly fine. That's a trinomial, so it actually fits in our part B category. But what we need to know is that the leading coefficient's 1. It's not 2 anymore because we factored that out. That leading coefficient's 1, which means if it'll factor, we can go right to this step. We don't have to do the factor by grouping step. So we're trying to find numbers that multiply to be negative 56 and add to be negative 1. So go through your head and you think about all the multiples of 56. Okay? And they have to be close together because when you add a positive and a negative, it's going to be 1. So how about a negative 8 and a positive 7? And that just takes practice, folks. So what I'm doing in my mind is I'm going through everything that multiplies to give me 56. And I go to the things that I think of first is like 7 and 8. And then I think, well, it has to add to be negative 1. And I know one's positive and one's negative because of the multiply. And it adds to be negative 1, which means the bigger one is negative. So this is going to be x minus 8, x plus 7. Or you could write x plus 7 times x minus 8. But the 2 is required. Don't forget that in the middle of the process and just leave it hanging. All right, I've got 2 more problems for you that I want to make sure that we know how to do. Factor the polynomial completely. So I think about my strategy first. Is there a greatest common factor? Is there something common to all 4 of these terms? And there's not. I'm looking at the numbers first. I got a 1, a 2, a negative 1, a negative 2. There's not a factor there that's common. I'm looking at the x's. Well, the last term, the constant down here, doesn't have an x, so still nothing in common. Now what I do notice is I got 4 terms. Whenever you have 4 terms, factor by grouping is the way to go. So I'll look at the first 2, and I pull out an x squared. Okay, so x squared comes out of there. That's going to leave me with an x from here, plus, if x squared comes out of there, 2 there. Now keep in mind, when you do the second part of factor by grouping, you need to factor a greatest common factor out of these last 2 guys that will leave an x plus 2 inside. Okay, so if I pulled out a 1, they don't have anything in common. So if I pulled out a 1, that's not going to be what I need because that would leave me with negative x minus 2. But now if I pull out a negative 1, that's going to change that to a positive x and a plus 2. That's what we need. Now don't stop there. I see so many students stop there. That's not factored because there's a big subtraction in the middle. You have to write down the common factor, x plus 2, only once, times x squared minus 1. Now a lot of us would just circle that and move on. But check this out. That factors further. That's a difference of squares. Subtraction, x squared is a perfect square, 1's a perfect square. So the x plus 2 is still part of your answer. And when I factors this difference of squares, the square root of x squared is x in the first spot. Square root of 1 is 1 in the second spot, with 1 positive and 1 negative inside our factors. And that is completely factored. And for our final problem, so I'm looking for a greatest common factor. Notice this one has 1, 48 and 3. They don't look right off the bat like they would have a common factor, but 3 divides into 48 as well as dividing into 3. You know, a quick check to see if a number is divisible by 3 is you can add the digits together. Like 4 plus 8 is 12. And if that sum is divisible by 3, then their original number. So 12 is divisible by 3, it means 48 is. It doesn't work for all numbers. It works for 3, okay? So don't try that with a 5 or a 7 or something. It only works with 3s. So I'm going to pull out that common 3 and the x squared, okay? So 3 divides into 48. Turns out it's 16 times. And if I pull out x squared, that leaves me x squared. Minus... Now, this gets interesting. 3 into 3 is 1. X squared divided into x squared is 1. So that just leaves me with 1. Don't put nothing or 0, because really, this is what's happening, right? Those all cancel to give you 1. Now, we're not finished with this problem, because what you have here is a difference of squares. So 3x squared is part of our answer. Remember, a difference of squares is 1 plus and 1 minus. Whatever the square root of the first term is goes in the first position. So the square root of 16 is 4. The square root of x squared is x. First position. Square root of 1 is 1. Square root of 1 is 1. Second position. Then you look to see if that can be factored further, and it can't. Okay, when you get to an x to the first, you know you're finished. And then this x squared up front is it's not, you know, it's a monomial, so it won't go any further. It means one term. So you're completely finished factoring, and if you wanted to check it, you could distribute this back inside to make sure that's right. You can multiply this out and make sure that's right. But we've got it right. I hope this review of factoring helps you out a lot. There are many sections that require factoring in pre-calculus, so I'm hoping this will bring back all those old factoring techniques you learned in the past.